All right, hey guys, obviously I'm not here today because I'm recording this. So I'm gonna go over your hydrocarbon number 2 worksheet. So take that out. I'll give you a little time. Again, it's weird when no one's here. So take out your homework. If you didn't do it, then I guess you're getting a freebie because I'm gonna go over all the answers to the homework. So take your homework out, take out reference tables. We're gonna be talking about table R today as well. So the plan is here, I will go over the homework, then I will do a couple examples of, one example of an isomer, an example of branched alkenes, and then I will talk about table R, and that's going to be it, so it shouldn't be too long. Then you're going to get 2 worksheets, they're up here, 2 worksheets. Finish them in class if possible. If not, finish them for homework. I will check them tomorrow. Also, don't forget your take-home quiz is due tomorrow as well. All right, here we go. So, number 1 on the homework. The structure had 3 carbons and then kind of 2 coming down. The name of that structure would be, let's see here. So we have CH3, CH, CH3, CH2 and CH3. So this is kind of tricky here. 1, 2, 3, 4. That would be our main chain there. So that would be 1, 2, 3, 4 butane, and that's a methyl group. So 2 methyl butane. 2 methyl butane would be the name for number 1. I'm going to go kind of quick, so stay with me here. Number 2. What is the name of the following structure? Let's see here. CH3, CH, we got CH2, CH3, CH2, CH2, CH3. We got to count the chain, put the longest number of carbons. 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5, 6. So this is the longest chain. I drew these, or I put these on here this way to kind of confuse you on purpose, just so you can see that they can look different, not just a straight line. So anyways, that's a methyl. 1, 2, 3, 4, 5, 6, that's hexane. So 1, 2, 3 methyl, we want 3, right? We don't go 1, 2, 3, 4, because we're gonna go for the love. So 1, 2, 3, 3 methyl, hexane. That's the answer to number 2 here. And I know this is going to be shown to period 2 and period 5. Period 2, I think we went through some of these, but period 5 we didn't, so bear with me here. So that's that. Number 3, condensed structural, 2,3 dimethylhexane. So condensed is where we only show carbon-carbon bonds. We don't show carbon-hydrogen. So CH3, CH, because I need a methyl, right? There's my 2 methyl, so 1, 2, 3. So another CH, and you can put this methyl down or up, doesn't matter. I'll put it down. So there's 1, 2 methyl, 3 methyl, and then hexane would be the long chain, right? 1, 2, 3, 4, 5, 6. So there's 2, 3 dimethylhexane. So that was number 3. Again, I'm going quick, so stay with me. Number 4, 3, 3, 6 trimethyl-octane. Again, condensed structural. So 1, 2, 3 with a methyl, and then another methyl underneath it. Here's why. It says 3, 3. That means the third has 2 methyl groups. 1 up, 1 down. So 1, 2, 3, 4, 5, and then again 6 here. 6 will have a methyl. It doesn't matter if you go up or down with it. Doesn't matter. That's 6. So now 7, 8, and that's our octane. So 3, 3, 6 trimethyl, and then there's octane. So that's the first number for this number 4 over here. I got 2 4s for some reason. So that's this one. All right, the other number 4. The other number 4, 4-ethyl 2-methylhexane, structural, meaning we show all the bonds. So I'm starting with hexane. 1, 2, 3, 4, 5, 6. I always kind of start with the last part of the name first, right? That's hexane. And then you can go through and put all your bonds on. Okay, that one's kind of messy. So you can do that. So that's hexane. 2-methyl, 1, 2. So I have a CH3 here, that's a methyl. And then 4-ethyl, 1, 2, 3, 4. So off of this, there's an ethyl group, which means 2 carbons connected to each other. We don't want to put 1 C here and 1 C here, because that's 2 methyl groups. We want 1 ethyl. So 1, 2, 3, 4, off of the 4th one, we're going to have 2 carbons connected to each other. So right here, that's your ethyl. That's your ethyl group right there, and that's a methyl. So that's 2-methyl, 4-ethyl. So then put it all together, 4-ethyl, 2-methyl hexane. That's the answer to number 4 on the side here. All right, so that was number 4. I'll leave that up for a little bit longer here. All right, so now number 5. Number 5, apparently that name is wrong. What's the real name of the structure? So what I would do, or what you should do, is draw that structure given and then rename it. So pentane, 1, 2, 3, 4, 5. Put all my bonds on there. Remember, each carbon gets 4 bonds. So there's pentane, 2, 3 dimethyl. So 2, 3, they both have methyl groups. And then 4 is ethyl. So 4, and then we're going to do another 2 carbon. Right, 2, that's ethyl. So this is saying that's not the name. What is the name? Well, it's probably the longest chain that is screwed up here, right? So let's see, 1, 2, 3, 4, 5. That appears to be the longest, but it isn't. 1, 2, 3, 4, 5, 6. So my longest chain pops up here. So that's hexane. 1, 2, 3, 4, 5, 6. And then I have 3 methyl groups, so it's going to be trimethyl hexane. Trimethylhexane. Now we just have to number it. So 1, 2, 3, 4. So 2, 3, 4, or 1, 2, 3, 4, 5. So 3, 4, 5 are bigger numbers than 2, 3, 4. So we're going 2, 3, 4 trimethylhexane. That's the correct name for number 5. All right. So that's that one. Number 6 and 7, I'll put them both up at the same time. So number 6, 2-methylbutane. This is easy at this point. This should not be difficult for anybody, I would hope. 2-methylbutane. If you put this C here, that's perfectly fine. Remember, these exist in real life. They're 3-dimensional. They move around. So if I took this and I flipped it, right, if I could magically take this off the board and put it back on, this C really would be that C, right? So if you put this methyl off of here, in other words, you counted from this direction, that's the same thing as what I did. Okay? So that's 2-methyl, and then 7 would be 2,2-dimethylpropane. 1, 2, 3, there's my propane, there's a methyl, right? 2,2-dimethylpropane. Just make sure each carbon has 4 bonds. And there's the answers to 6 and 7. Number 8, what is the difference between them? The answer is number 2, structural formulas. These are called isomers. 1, 2, 3, 4, 5. They're both C5H12. They're both alkenes. They're both saturated, right? Saturated with hydrogens because they're all single bonds. So the molecular equation, molecular formula is exactly the same. Same number of atoms. It's just rearranged. We talked about that, how it's kind of like twins a little bit. Another analogy I use sometimes with isomers, Mr. Potato Head. If you had 2 Mr. Potato Heads, you could take the pieces and put them wherever you want. I mean, you could put the ear in the nose hole, you could put the legs coming out of the eyes or whatever, you know, it's weird, but you could kind of have a normal Mr. Potato Head and then you could rearrange it so it looks different, and it's a decent analogy, I don't know. In other words, all the same pieces, same number of pieces, right, parts, just rearranged differently, and that's what isomers are, right? We talked about it last week. This one, remember, would have a lower boiling point, more branches. It's more like a ball, so less surface area. Something that's more straight chain. More straight chains mean straighter chain means more surface area, more contact, and that would be higher boiling point. So properties change for isomers, like boiling point. So anyways, that was 6, 7, and 8. Let's put that away. Let's take out our notes. Your reference tables should be out. All right, I'll give you like a minute to do that, to put that away. Take out reference tables P, Q, and R, and your notes. I'm going to draw a structure for an alkene, and then I'm going to give a name for an alkene, and I'll explain how to go over how to do both of those, and then we'll practice isomers one more time, and then real quick kind of go through table R just so you can do this worksheet that I have up here on table R. Nothing too heavy, just kind of using R and make sure you can read it. All right, so here we go. So I'm going to give you a name over here and a structure over here, and then I'll try and wait a little bit so you can try and name it and draw it. But again, it's weird when no one's in here, so I'll do my best here to wait. Here we go. So I'm going to draw one here. All right, let's go. Let's see, 1, 2, 3, 4, 5, 6. And we're going to go, let's see here, put a C here. Let's see. All right, so go ahead and draw that. So you got 1, 2, 3, 4, 5, 6 carbons. You got a carbon coming off the second, well, anyways, may or may not be the second one, but off of this carbon you have this carbon branched off, okay? It's an alkene, right, unsaturated. Double bond. So go ahead and draw that. Try and name it. So while you're doing that, I'm going to write a name over there and see if you can draw that. So get working on that. So give me the name of that, and I'll get out of the way. Let me give you a name here. Go 3-methyl 2-pentene. I hope you can see that in the camera. I think you can. So 3-methyl 2-pentene. So now I'm going to wait a couple minutes here. You're naming that one. You're drawing the structure for this one. All right, I'm gonna jump back in here just because I just looked and it's like almost 15 minutes. I want to try and get this 20 minutes here. We'll see. All right, so Same rules as naming alkanes. Find the longest chain, put a box around it. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Let's just keep it straight, makes it easier. So we box it, circle everything outside the box. Let's name inside the box 1, 2, 3, 4, 5, 6. So that's hexene, right? Hexene, because of double bond. Now we need a number to tell me where the double bond is. So 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So either way I count this, the double bond is on the third carbon. So it doesn't matter which way I count. However, the methyl group here could be on the second or the fifth. So it doesn't matter for the double bond which way we count, but it does matter for this. So I would say 1, 2, 3. So this is 2, this is 3, because 2 is lower than 5. So if we counted 1, 2, 3, 4, 5, that would be 5 methyl. Instead, 2 is better. 2 is lower. So this is 2 methyl. So this here is called 3 hexene. This is 2 methyl. So let's put it all together. 2 methyl, 3 hexene. That's the name of that. That's the name of that structure. Again, it's unsaturated because it's missing its hydrogens. It's not saturated with hydrogens. So 2-methyl 3-hexene would be the name of that. All right. Hopefully we're good. Obviously, I can't take questions. So 3-methyl 2-pentene. So now let's draw this. We start with the pentene. 1, 2, 3, 4, 5. Right? 5 means pent, or pent means 5. Ene means double bond. Where is the double bond? It's on the second carbon. 1, 2. So the double bond is here, not here. If the double bond was here, that would be 1 pentene. So this is the second carbon, that's where the double bond goes, between the second and third. Now the third carbon here has a methyl. You can go up or down with it. Let's go down. So now notice, this carbon has 1, 2, 3, 4 bonds. So it doesn't get a dash, it doesn't get a bond up here. This is empty. This one has 1, 2, 3, so 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This one's done. 1, 2, 3, 4. 1, 2, 3, 4. So that's 3-methyl 2-pentene. That would be the structure for that. And that's like literally as hard as you'd ever see for this type of question. All right. So copy that down. 3-methyl 2-pentene. You're going to practice on this worksheet you're going to get. Doing more of this stuff. All right. So now real quick, I'm going to go through isomers here. So I'm going to draw a structure here. Let's see. I'll just keep it simple. We'll do butane. So there's butane. Copy that down real quick. All right. I always do that. So there's butane. There's butane. So we want to draw an isomer of butane. So what we have to do, we have the same molecular, right? 1, 2, 3, 4. So that's C4H10, right? And the way to get that formula, we could just count them up, or we use the general formula on table Q and plug the number in for N, right? So 4 in for N. And this is 2N plus 2, so that's 10. I hope you're following me there. So anyways, this is an alkane, saturated, single bonds, C4H10. I want to draw an isomer next to it that has the same number of carbons and hydrogens, but it looks different, different structure, and it has a different name. I'm going quick here, so I will give you guys 30 seconds to do that. So draw a structure over here in your notes that is an isomer of this, so it has a different name, but the same number of atoms, right? So same molecular. So again, I'll give you 30 seconds, draw the isomer and name it. Draw the isomer and name it. All right, that was about 30 seconds, a little bit more actually, but here we go. There's really only a couple isomers you could draw. We can take one of these C's on the end and put it off, branching off of one in the middle. Do not do this. That's wrong. That still is butane. 1, 2, 3, 4. It's just bent. It's still the same chain, right? Don't do that. That's not right. I mean, if you did, it's okay. This is why we're doing this, right? To learn what to do. Instead of taking this carbon and just kind of bending it, let's take it off and then attach it to one of the middle ones. So actually, this would not be one of the middle ones. You would have to stick it on this. That's really all we could do. So let's take this carbon and then put it down here. So that would look like this. That's an isomer of butane, and this would be called 2-methylpropane. 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 And that's actually all we can do. There's not another one we can make because if we take this carbon and put it here, then that's 3 in a row here, and that would be 2-methyl. So really, 2-methylpropane is all we can do. So butane only has one isomer, 2-methylpropane. If I was to draw out another carbon here and have pentane, there's more isomers. If it's hexane, even more. So the longer the straight chain, the more isomers you can do, the more you can rearrange it. That's basically all we can do. 2-methylpropane, that is the isomer. Oh, we don't need that dash, sorry. That's the only isomer for this, okay? So again, if you counted them up, it would be C4H10, and again, that is the definition of an isomer. Same molecular formula, different structure. All right, so I'm kind of hammering isomers a little bit. The worksheet's going to practice more of these. Moving on. All right, now real quick here, go to table R, and what I'm going to do is I'm going to give you this worksheet here, and on this worksheet it says classify the compounds according to their functional groups. So I'm just going to go through table R. I'm going to put it up on the projector and explain how you would look at a compound and identify the functional group, and that's what you're going to do here. So I'll write a couple of these on the board and show you exactly how to do it. All right, so here we go. Let me get this up there, and I'll make this as fast as I can because I'm already over 20 minutes. What else is new? I talk too much. All right, so again, table R should be out, so you can follow me here. And I got it kind of blown up a little bit, so we'll go through it kind of slow. Well, not that slow, but anyways. Okay, so on table R, it says organic functional groups. What the heck is a functional group? Well, the name is over here where it says class of compound. That's the functional group. That's the name of the functional group, and then here it shows you. So all alcohol, so any alcohol compound in the world will have an OH group. So if you look at the formula, or the structure I should say, for an alcohol, you're always looking for that OH. If you see a whole bunch of C's and H's with an OH, it's an alcohol. So that's an example of one of these functional groups. And what is the point? If you take these OHs here, or you take these functional groups, and you stick them on a chain. So this is ethane. If I take this hydrogen off, and I put, this is an O and an H, the red one's O, and the yellow one's H. If I put an OH on here, this becomes ethanol, and this is now an alcohol. That just changed the properties of ethane. So functional groups change the properties, and the organic compounds can be used for different things. So that's what functional groups, that's why we're learning it, and that's their purpose. But can you identify them? That's what we're going to go through here real quick, and that's what the worksheet is practicing. So anything with an OH, you say is an alcohol. Anything with an O in the middle of the chain, see how there's a C and then C's on the side here, so C on the left, C's on the right. Anytime there's an O in the middle, that's called an ether. That's how we say that, ether. All right? So that's what you're looking for on the worksheet, is anything with an O in the middle, you're going to say, oh, that's an ether. That's all you're doing on the worksheet, telling me, oh, it's an alcohol, oh, it's an ether. That's it. Okay? Again, I'm going quick, and we're not going to have a whole lot of examples, but hopefully the worksheet will be good practice. All right, so that's ether. The next, I can do probably 3 of them here. the next three, we have aldehyde, ketone, organic acid. So again, you're looking for this functional group in the compound. So propanol here has the C double bond O with the H. If you see that in a compound, then you say, all right, that's an aldehyde. Ketone looks similar, right? It's a C double bond O, but notice the aldehyde has the H, ketones do not. So the aldehyde's always actually at the end of the chain, whereas ketone's in the middle. Obviously, you can use table R on the worksheet. So what you're doing is you're using the examples here, looking at the functional group and seeing, okay, C double bond O, C double bond O. Oh, that's a ketone. C double bond O with an H, C double bond O with an H. That's an aldehyde. But if you see a C double bond O with an OH, right, they're all similar, but just a little different. C double bond O with an OH, C double bond O with an OH, that's an organic acid. Organic acid, what the heck's that? Vinegar. Vinegar is an organic acid, actually. Again, the worksheet, you're going to be given examples like this, and you're just going to have to circle the functional group. I don't know if the directions say that. I want you to circle the functional group on the worksheet. It doesn't say that. I'm going to say that again. On that worksheet, with the functional group, circle your functional group just like I'm doing, and then on the line, write down what the name of it is, okay? What class of compound it is. So that's what I want you to do. So that's those three. And the last three here, this is called ester, not ester. Ester, amine, and amide. And ester is hard to recognize, kind of. It looks kind of like the ketone and the aldehyde and the organic acid because it has a C double bond O, but this one's different. It has C double bond O with an O next to it. C double bond O with an O, no H. See, there's the H for the acid, there's no H there. So the acid's always at the end, but the organic, or the ester's in the middle. And I know some of you are probably like, what? This is confusing. I get it. Let's just kind of get the ball rolling with this. So there's your ester group. I see that right here. Oh, that means this is an ester. So that's all you have to do is tell me that's an ester. The amine and the amides are easier. They have N's in them. The only difference is the amine is just an N there's just an N, usually an NH2. Usually an NH2, or at least just an N with some H's. That's the amine group. But the amide, or the amide some people say, has a C double bond O with an N. So if you see the C double bond O with an N, you see that together, that's your amide or your amide group, whereas the amine would be just the N and usually some H's with it. So what I want you to do when you get this worksheet real soon here, use the examples, all right, match them up with the name here, use the examples in the chart to compare to what you see on the worksheet. Okay, I'm actually going to stop real soon here. I'll just let you work on the worksheet, and that'll be good enough practice. Tomorrow we'll go over it, okay? So you're going to get this worksheet here, you're going to get this worksheet here, all right, front, and a couple on some on the back. Both of these work on right now. Whatever you don't get done, it's homework. I know you got the take-home quiz, but you've had that for a while, and like you guys know, we're pressed for time, so we got to cram some work in here. We got to do some work. So I appreciate you paying attention, and hopefully, you know, understanding what I'm doing, because I'm not here today. I'll see you guys tomorrow, and I guess that's it. All right, have a good day.